we are doing indicator 27 now. And the learning target, as you can see, I can solve one-step addition equations. And when I'm saying addition, that means addition and subtraction equations, and one-step multiplication and division equations, demonstrating how I used properties of equality. And the properties of equality, you have the addition property of equality, subtraction, multiplication, division. So basically, the vocabulary was like if I say inverse operations, inverse operations are basically used to solve these problems. And, inverse operations, they undo each other. Okay, undo each other, meaning one cancels the other one out. So basically, it's the opposite operation. For example, addition will undo subtraction. Subtraction will undo addition. Multiplication will undo division, and division will undo multiplication because they are the opposite of each other. Okay, so addition property of equality. So we're going to start with a problem so that you understand what I'm saying. Basically, addition property of equality. Let's say I have a number and I say 8 is equal to 8. Okay, and if I add the same number to both sides of that equation, both sides are going to remain the same. So if I say plus 5, whatever I do to one side of the equation, because it is a balance, I have to do the same thing on the other side of the equation. So if I'm adding 5 here, I have to add 5 here. And so when I'm adding this same number on both sides, 8 plus 5 gives me 13. And I get 13. So look, both sides are balanced. So basically, addition property of equality is if I'm adding a number, the same number to both sides of the equality, it does not change the sum. Subtraction property will be the other way around. If I subtract the same number from both sides of the equation, let's just say if I was just doing 8 is equal to 8 over here, okay? And then I go ahead and I subtract the same number, so I'll just go ahead and use the same number, which is 5 here. Now it's a subtraction, so minus 5. Whatever I do on one side, I have to do the same thing on the other side of the equation. So when I subtract the same number from both sides of the equation, that's not going to change because 8 minus 5 is 3, 8 minus 5 is 3. So it's not going to change that difference, okay? So that's basically what these properties mean. So let me go ahead and solve some problems so you understand what we're doing, okay? All right. So let me give you a problem, and if it says solve, and right now I'm giving you pretty simple ones. However, you have got to show the properties when you're solving it. Okay, that's a requirement. So if I say x minus 2 is equal to 6, you have got to show the property. So you basically look at the number that is attached to the variable. Okay, now right now this is pretty simple. Who doesn't know minus 2 is going to give me 6? So basically, obviously, it will be 8. Okay, you can do that reasoning. But when you're using the properties, you've got to show how the signs are undoing each other. So, and you always have to look at the number that is attached to the variable because that is the part that needs to be worked on, okay? So in this case, if I look here, attached to my variable is the minus 2, okay? So we are going to undo the subtraction. So whatever I do, I have to get rid of this one. So what is the opposite of minus 2? It would be plus 2, right? So I would do plus 2 here, and whatever I do on one side of the equation, I have to do the same thing on the other side of the equation. So that, because I'm adding, this is the addition property of equality. Okay, equality because it's an equation. You have the equal to sign in the middle. Okay, so if I'm adding 2 here, please don't try to add 6 or subtract 6 or whatever, because 6 is not attached to the variable. What's attached to the variable is the minus 2. So then when I do, this is basically saying you have 2 and you take away 2. So opposite signs are going to cancel each other out. Okay, so I'm left with x is equal to 6 plus 2 is 8. So this is my final answer. Always check your work. To check your work, you make sure that, look, you're going to say the original equation. So you will write x minus 2 is equal to 8. Then we solved it, and when we solved it, we said x is equal to 8. So we are going to use substitution. And instead of x, I am going to write 8 minus 2 is equal to, sorry, this is 6. Is equal to 6. X minus 2 is equal to 6. So 8 minus 2 is equal to 6. And then 8 minus 2 is 6 is equal to 6. And so when you look at this, yes, both sides are equal. So this is correct. Now, if you had made a mistake, this is the place where you would actually catch it. Because when you are subtracting, and if you get anything else, if you get 7 is equal to 6, there's something wrong in that picture, because equal to means both sides are a balance, have to be the same number. So when you get a different answer here, you want to go back and check your work on the top as to where you could have gone wrong in the subtraction or addition in this case, okay? All right, so let's do another problem. And if I say 18 is equal to x minus 7, all right, you can also write this, you can write it like this, it doesn't matter. But because there's an equal to sign, if some of you choose to write it like this, that is also fine. Okay, if you're going to solve it that way. Just want to show that to you because it's an equality. Both sides are the same, but do not change the sign around. Okay, so once you have this, okay, I'm going to look at what's attached to the variable. The minus 7 is attached to the variable. Okay, and so opposite of minus 7 is plus 7. Whatever I do on one side of the equality, I have to do on the other side of the equality. And since I'm adding both sides, this is my addition property of equality. Okay, and so I'm adding 7 to both sides of that equation. And even if you had turned it around and done it, the one that I was showing you that you can do it this way, that is perfectly fine. Okay, and so 8 plus 7, we have 15, carry over 1, that's 25, is equal to, this is going to cancel each other out, is equal to x. So x is equal to 25. Same thing over here. You could have just done, if you had taken it and switched it around, you would do plus 7, and then we have the minus and the plus over here cancel each other out. X is equal to 25. Okay? To check your work, take your original equation, which is 18 is equal to x minus 7, and then we said x is equal to 25, so 25 minus 7, and so when you subtract 25 minus 7, yes, I end up with 18, so I know this is correct. Okay, so always check your work to make sure that you are on the right track. Okay, so this was all using the addition property of equality. Let's go ahead and solve a problem with the subtraction property of equality. Okay, subtraction property of equality. So let's say I give you x plus 2 is equal to 9. Okay, now look, what do we have attached to the variable? We have a plus 2 attached. And the opposite of addition is subtraction. So we are going to use the subtraction property of equality. because this minus is the inverse of plus. Okay, so minus 2, whatever I do on one side of the equation of the equality, I do the same thing on the other side of that equality. So minus 2 over here. And so then I have the 2 minus 2 gives me 0. Nothing is there. And x is equal to 9 minus 2 and I get 7. Okay? If you check your work, take your original equation, which is x plus 2 is equal to 9. And then I found out that x is equal to 7. So I'm going to substitute x with 7 plus 2 is equal to 9. So yes, 9 is equal to 9. This is correct when I'm solving x is equal to 7. So always check your work, all right? Let's say I have a problem which involves, so this is subtraction. Now this is the absolute opposite of your addition property. So when you have the plus, you do the opposite, which is subtraction, okay? Then let's go on to multiplication division. Again, it functions on the same philosophy, and opposite of multiplication would be division. Opposite of division will be multiplication, okay? So let me show you. There are two ways to show your multiplication. So if I give you a problem and I say W divided by 4 is equal to 12. Okay? Please remember the fraction sign means division. Fraction sign means division. Please remember that. Okay? So, since this is division, the opposite of division would be multiplication, because multiplication is going to undo division. Okay, it's the inverse operation. So I'm going to use the multiplication property of equality. Okay, so I'm looking at what is attached to the variable. Okay, and the variable is attached to 4. So that is why, since that is the division part, I have to use multiplication by 4 on both sides. Okay, so then I do this times 4 times 4, because whatever I do on one side of the equation, I have to do the same thing on the other side of the equation. All right, now if I did this as a fraction form, I would do over 1. And you know that anything from the numerator to the denominator can be simplified in a fraction. So 4 divided by 4, I would actually end up with 1. And so I'm left with just W. I'm just left with W is equal to 12 times 4, which is 48. Okay? And to check your work, you would write the original equation, and you would do this, and I would substitute the value for W, which is 48 divided by 4 is equal to 12, and then I can see, yes, 12 is equal to 12. So this is correct. So this is correct. Okay? The same thing, I want to show you that you can write it in a different way. You can also write this like this. W divided by 4 is equal to 12. You can also, because the fraction line is nothing but division. So if you have this, all you do now is, since this is attached to the variable, I would do times 4. Whatever I do on this side of the equality, I do the same thing on the other side of the equality. And then the multiplication cancels the division out. I'm left with W is equal to 12 times 4, which is 48. So you are welcome to show it this way also. Okay, so again, same thing. Opposite of division is multiplication. All right, and it's going to cross each other out. Let's do one which involves division. All right, So if I say solve if I say solve 5b is equal to 65. Okay, again, please look at what is attached to the variable. The coefficient is attached to the variable. Coefficient next to the variable means it is multiplication, all right? So what times that coefficient is going to give me 65? So that's what I'm trying to basically solve, okay? So again, there are two ways that you can do this. First and foremost, opposite of multiplication is division. So I would use the division property of equality. Please remember, we are using the inverse operation to undo the operation. Okay? So, if I have opposite of multiplication is division, I am going to divide both sides by 5. Okay? And 5 divided by 5 gives me 1. Please don't write 0. Okay? Please don't write 0. So, 5 divided by 5 gives me 1. And 1 times b, or anything times 1 is a number itself. So, 1 times b is b. Okay? B. And then I have 6 divided by 5 is 1. 1 remainder, so I get 13. Alright? So, b is equal to 13. So now I check my work. I take the original equation where it's saying 5b is equal to 65, and this means 5 times b is 13 is equal to 65. So 3 times 5, 15, carry over 1, and 1 times 5, 1 plus 1 is 65 is equal to 65. So this is correct. Always check your work, okay? Another thing that I don't care if you write it this way, if you have written 5b is equal to 65, we know this is multiplication, so the opposite is division. If you choose to write it like this, divided by 5, let me write it with red so you can see. Because opposite of multiplication is division. So if you chose to write it divided by 5 on both sides, that is perfectly fine also, because the multiplication and division will cancel each other out, and I have b is equal to 13 when I divide 65 by 5. So this way also you are welcome to choose this method, okay? So basically that's what this lesson is about. You might have a fraction. So you've got to know that, let me show you one for example. Please don't assume that you'll always get a whole number. Okay? So if I give you something in the classroom and you might even have a decimal. So don't assume that it's always a whole number. Okay? So if I'm solving for, let's say, z, and I'm saying z minus 1/3 is equal to 4. Okay, so guess what? What is attached to the variable? It is minus 1/3. Okay, now just because you see a fraction, there is no reason for you to have a heart attack. Okay, it's perfectly okay. So now we are going to try to remove 1/3 from there. So the opposite of subtraction is addition. So therefore we are going to add 1/3 to both sides of this equality, and the minus plus cancel each other out, and we have z is equal to, you have 4 as a whole number plus you have 1/3, so therefore guess what, this is going to be 4 and 1/3, And there is your answer, because you have 4 whole parts and you have 1/3 of a part. So then you bring them together and you squish them together, it becomes 4 and 1/3. Or you're welcome to do the long method of finding the least common denominator and then bringing it back to the mixed number, and that's perfectly fine also. Okay. Once again, you might have a decimal also in your problem, and then you know how to multiply, divide, add, subtract decimals. I just showed you the examples basically with whole numbers right now, so that you understand what these properties mean. And please remember that the opposite signs undo each other. So that's basically what we're doing. Do not touch the number which is on its own, okay? Because sometimes children tend to do that. You are basically adding, subtracting, multiplying, or dividing the number that is attached to the variable. And that's the number you choose to perform the operation on both sides of the equality in order to solve it. And please make sure that you definitely check your work at the end. In this case, for example, if I had checked my work, I would have done 4 and 1/3. I would have put that over here. Okay, z is 4 and 1/3. And from this, if I subtract 1/3, guess what? The 1/3 and 1/3 are subtracted. So I will be left with 4. Okay, so then that shows me that my answer that I got is correct. All right, so this is the conclusion of indicator 27. Have a great day, guys.